In this video, we'll continue our look at quadratic functions. Last time we looked at the vertex form. This time we're going to look at the standard form. So as you can see here, the standard form is y equals ax squared plus bx plus c, where the a, the b, and the c are constants. The a value cannot be 0 because if the a value is 0, it would be 0 times x squared, and therefore we wouldn't have a squared term, so we would just be left with a linear equation. So to be a quadratic in standard form, this a value must not be 0. It can be anything else, it just can't be 0. So looking at the characteristics, I've got the vertex form marked out because we talked about that last time. So standard form, y equals ax squared plus bx plus c. So the vertex, how do we find it? It's negative b over 2a, and when it's talking about negative b over 2a, it's that b, the opposite sign of it, over 2 times that a right there. That gives you the x coordinate of the vertex, and then you have to evaluate the function at that x value to get the y value of the vertex. So that's what they're talking about here. Again, axis of symmetry is negative b over 2a for the x coordinate of the vertex, which is also the value for the axis of symmetry. Axis of symmetry is a vertical line, so it's always specified as x equals a number. The y-intercept will be 0, c, so standard form gives us the y-intercept, because if x is 0, that's what happens when we intercept the y-axis, the x-coordinate is 0, so that term is gone and that term is gone because x is 0, and you're only left with this. So the y-intercept is given to you right there in standard form. Point symmetric to the y-intercept, so we talked about that last time. Due to the symmetry of a parabola, we can find that point. We'll do that later. X-intercepts, we did this last time as well, and we'll use our calculator at this point. Later in the next unit we'll be solving, and we can find those x-intercepts algebraically. For now we're using our calculator. So let's look at this first example right here. So the most important thing to do with standard form when you begin is to identify your a, b, and c values. So a is 1, b is negative 2, and c is negative 3. So there's an implied 1 right there, there's a negative 2 in place of b, there's a negative 3 in place of c. So that's where these values are coming from. So the vertex is defined as negative b over 2a, I'm writing small here. So for us, that's going to be the opposite of negative 2 because it's negative b. So that'd be a positive 2 over 2 times a is 1, so 2 times 1. So 2 divided by 2 is 1. So the x coordinate of the vertex is 1. So now we need to, we can get the axis of symmetry from that, x equals 1. So we need the y coordinate of the vertex. So we evaluate this function when x is 1. So we do f of 1. So that would be 1 squared minus 2 times x is 1 minus 3. So 1 squared is 1, negative 2 times 1 is negative 2. Subtract 3 from that, so that would be 1 subtract 5, so negative 4. So the vertex here is 1, negative 4. The y-intercept is given by the c value, so the c value here was negative 3, so it's 0, negative 3, the y-intercept. For the symmetric point, we'll start a rough sketch here. So let's put in our coordinate plane here. Make a very small sketch, and we have a axis of symmetry of x equals 1 right here, and we have the y-intercept is 0, negative 3, so down here like this. So let's label that 0, negative 3, and we have a axis of symmetry of x equals 1 here, so the reflected point would be 1 away from the axis of symmetry, so that would be at an x value of 2. The y value stays the same, so 2, negative 3 would be the point symmetrical. The x-intercepts, we'll use our calculator to find those. So put the function in, x squared, subtract 2x, subtract 3, and in y2 we're going to graph y equals 0. This was the preferred method for the majority of students, so we'll stick with it. So when we graph y equals 0, we're putting a horizontal line right on top of the x-axis there. And we can just find the intersection. Second trace, option 5, I'll hit enter 3 times to find the first one, negative 1, 0. I'll do the same thing again, second trace, option 5. Hit enter twice for first curve and second curve. For the guess, it looks like it's at about 3 right here, so I'm going to just type 3, hit enter, and in fact it is. So 3, 0. So that was the preferred method. You could also use the 0 method, second trace, option 2. Most students don't like that. I'm not going through that again. When you can do it the intersection method, that works. You can double check with your table since we have whole number x-intercepts. So negative 1, 0 is there, check, and 3, 0 is there, check. All right, second, and it'll be the last example for this video. So the first thing we do is identify our A, B, and C. Again, this is the standard form right here. So we want the A value is this implied negative 1 right there. The B value is the number in front of x there, so that would be positive 6. The C value is the last one, negative 2. So we'll find the vertex by finding the x coordinate of the vertex, by finding negative b over 2a. So for us that would be negative 6 over 2 times a is negative 1. So that's negative 6 over negative 2. Negative 6 divided by negative 2 is positive 3. So the x coordinate of the vertex is 3. So x equals 3 is the axis of symmetry. Remember, the x coordinate of the vertex and the value of the axis of symmetry will always be the same. So now to find the y coordinate of the vertex here, we evaluate our function, this one right here, when x is 3. So we'll evaluate f of 3. So substitute in a 3 for x. So it would be negative 3 squared and plus 6 times x is 3, subtract 2. So 3 squared is 9 times negative 1 is negative 9. Plus 6 times 3 is 18, subtract 2. So negative 9 plus 18 is positive 9, then subtract that 2 would be 7. So the value of the vertex is 3, 7. Next we'll find the y-intercept. The y-intercept is 0, c. Well, our c value right here is negative 2, so 0, negative 2. So we can start plotting some of this. Our axis of symmetry is x equals 3, so we'll put a dashed vertical line at x equals 3. Label it x equals 3. And 3, 7 is our vertex, 3, 7 right here. Our y-intercept is 0, negative 2 right here. So the point's symmetrical. We know that the y coordinate needs to be negative 2. So we count 1, 2, 3 spaces. 1, 2, 3 spaces to the axis of symmetry. So we count that same amount to the right. 1, 2, 3. That takes us to 6. So 6, negative 2 is that other point right here. The x-intercepts, we'll find those using our calculator in just a moment. So vertex, we'll put that in the middle of our table. And that was 3, 7. And now let's find the x-intercept. So put the function in, negative x squared plus 6x, and subtract 2. We already have y equals 0 graphed for the on top of the x-axis there. So second trace, option 5 for intersection, first curve. Calculator asks you a series of questions here. First curve is the parabola, yes, hit enter. Second curve is the line y equals 0, yes, hit enter. Guess, I'm on top of that 0, so I'll just hit enter there. So we'll round to 2 decimal places, 0.35, 0. Find the second one, second trace, option 5. First curve, enter. Second curve, enter. Guess, it looks like 1, 2, 3, 4, 5. About 5.5, I'll say 6, and it'll find it for us. 5.65 rounded. 5.65, 0. So I'll put that right here, 5.650 and 0.350 here. We will now find some whole number points if we can. So let's go on our table. We have 0, -2 that we identified right here. We have 6, -2 if we look here in our table that we found right here. So we need one more point to the right, 7, -9, and we want one point to the left of 0, so -1, -9. Can you notice the symmetry of the parabola? We have these x values here are repeating down here. You see those repeating there. If we wanted to find and verify that f of 7 is equal to -9 or f of -1 is equal to -9, then we can do that. So let's find one of those right here. We'll evaluate this point and make sure it's accurate. So f of 7, x is 7, what is y? That's what we're finding. So that would be -7 squared plus 6 times 7, subtract 2. We just input a 7 for x there. So 7 squared is 49, make it negative, so -49, plus 7 times 6 is 42, subtract 2. -49 plus 42 is -7. Subtract 2 from that and we get -9, so check. This point checks out. Alright, that is it for this video on standard form. Alright, we need to come back and graph this. We didn't do that, so it opens down like this. That means that, it's terrible. Let's try that again. That means that this vertex is a maximum in this case, so we should list that there. Alright, now that is it for this video.